When we talk about AI security, our minds usually jump to hackers trying to fool a live model. But what if the attack already happened, months ago, before the model was even deployed? What if the real vulnerability isn't in your code, but in the very data you told your model to trust? Today, we're going to pull back the curtain on a really foundational and honestly an often overlooked threat: training data poisoning.
So what is this stuff exactly? Well, training data poisoning is just what it sounds like. An attacker deliberately slips malicious, corrupted data into your AI's training set. The source material has this fantastic analogy for it. It's like someone secretly adding wrong answers to a student's textbook right before a huge exam. The student studies like crazy, but they're learning flawed information from the very start. So of course, every single answer they give is going to be based on that faulty foundation.
And this is what makes it so uniquely dangerous for any business. See, unlike a normal software bug you can just patch, a poisoned model is fundamentally broken. The damage is baked right in, there's no quick fix. The only solution is to scrap it and start all over again with a complete and, believe me, very costly retraining. Just think about the downtime, the hit to your reputation, the loss of customer trust. It's a failure at the most basic level.
So here's what we're going to cover. First, we'll dive into why this is an unpatchable threat. Then we'll dissect the anatomy of an attack, see how this Trojan horse actually gets into your data. And then, the important part, we'll talk about building a multi-layer defense and wrap it all up with the zero-trust mindset you absolutely need to adopt. All right, first up, let's really get into what makes this threat so different from what you're used to. The danger is all about that pre-deployment corruption, and that just changes the entire security game. Now, this is what makes these attacks so terrifyingly efficient. You might think an attacker has to compromise a huge chunk of your data to do any real damage, but that is just not the case. Research shows that poisoning attacks can have a jaw-dropping 92% success rate by contaminating less than 0.1% of the training data. A few bad apples can truly spoil the entire barrel. And that perfectly illustrates what we call the persistence problem. Look, the attack itself could happen on a random Tuesday afternoon, months before you ever go live. But once that model is trained, the damage is permanent. It lives on, silently messing with every single prediction it makes out in the real world. The cause is way in the past, but the effect is continuous and, frankly, pretty insidious. So what are these attackers really after? Let's get into the anatomy of an attack, because not all data poisoners have the same endgame. Their methods are actually tailored to what they want to achieve. We can really break them down into three main types. First, you've got your availability attacks. Here, the goal is pretty simple. Just degrade the model's performance and make it unreliable. The tricky part is, this often just looks like a poorly trained model, which makes it super hard to spot as a malicious act. Second, and way more sinister, are integrity or backdoor attacks. Here, the goal is all about control. They create hidden triggers, all while the model seems to work perfectly. And finally, you have sleeper or time bomb attacks, which are designed to stay completely dormant, evading all your tests until the attacker decides to activate them later on. Let's just focus on those integrity attacks for a second, because they are incredibly sneaky. The key thing to understand here is that the goal isn't chaos, it's control. To your security team, your data scientists, all your validation tools, the model looks perfect. It aces all the accuracy benchmarks. The backdoor is completely invisible until the attacker decides to use their secret key, like a specific image or a weird phrase, to unlock the malicious behavior on command. Okay, so we know what these attacks look like and why they're so dangerous. But how does this poison actually get into the system in the first place? Let's talk about the real-world Trojan horse and why your AI supply chain is basically the new frontline. And this is the question every single security leader should be asking. Is this just some theoretical problem that academics worry about? Or is this actually happening right now, out in the wild? Well, the answer is a resounding yes. In 2024 alone, researchers found over 100 poisoned models on HuggingFace, one of the biggest and most popular platforms for sharing AI models and datasets. This is not a theory. This is a current, large-scale problem. And the findings from that incident? They're pretty chilling. These models had hidden backdoors, and just like we talked about, they passed all the standard performance tests with flying colors. But what's even worse? Traditional malware scanners completely missed the malicious behavior. Why? Because it wasn't a flaw in the code, it was subtly woven into the model's core logic.
Some of these were even capable of remote code execution. I mean, can you imagine the damage from that in a production environment?
So how did they get there? It all comes down to the AI supply chain. If your teams are using open datasets from places like HuggingFace or Kaggle, if they're scraping content from the web, buying data from third-party vendors, or even using crowdsourced labeling services, you have a potential entry point. And you really have to pay special attention to fine-tuning. That stage uses smaller datasets, which makes it an incredibly vulnerable spot, where just a few bad data points can have a massive impact.
All right, that is the problem, and yeah, it's a big one. But let's switch gears and talk about the solution. How do we actually fight back? Well, we have to build a multi-layered defense to protect the very foundation of our AI.
Look, an effective defense isn't about buying a single tool. It requires 5 distinct layers all working together. First, data provenance. This is all about knowing exactly where your data comes from, like a chain of custody for your information. Next up, anomaly detection, using statistical methods to find outliers that just don't look right. Third is robust training, which means using techniques to build resilience directly into the model itself. Fourth, we need strategic dataset curation and filtering to weed out suspicious data before it ever gets near the training process. And finally, continuous validation, because the job is not done at deployment. We have to keep an eye on the model's behavior in production. Let's zoom in on one of those robust training techniques for a second, differential privacy. It's a really interesting example of a strategic trade-off. Think of it this way. You're adding a little bit of mathematical noise to the data during training. Now, this noise is small enough that it doesn't really hurt the model's overall performance, but it's just big enough to drown out the signal from any single poison data point, basically making it harmless. So yeah, you might see a tiny dip in accuracy, but what you gain is a mathematically proven defense against these kinds of attacks. For any high-risk application, that is a trade-off worth making every single time.
Now, if you're wondering where on earth to start with all this, here is a quick win for you. Create a data bill of materials, or what some people call an AI bomb. It's simple, really. Just document all your training data sources, where they came from, and their verification status. This one step provides a level of visibility that most organizations are completely lacking today. And visibility, as we know, is always the first step toward security.
Finally, all of this defense-in-depth thinking leads us to a really necessary shift in our security culture. To truly manage this risk, we have to adopt a zero-trust mindset for our data pipelines.
This quote from the source material just sums it up perfectly. Treat the entire data pipeline as a zero-trust environment. No data source should be assumed safe simply because of its origin. I mean, I don't care if it's a free data set from the internet or a commercial one you paid millions for. Trust has to be earned and verified, not just assumed.
So let's quickly recap the most critical takeaways here. First, data poisoning is an unpatchable foundational threat with major business consequences. Second, remember that sophisticated attacks like backdoors are specifically designed to evade your standard tests. Third, your AI supply chain, all that data you pull from the outside, is your primary and probably your most vulnerable attack surface. And finally, defense is not a single tool. It requires multiple layers working together.
So I'll just leave you with this final thought. Your organization almost certainly has a software bill of materials, right? An SBOM, to tell you what's in your software. The question is, do you have an AI bill of materials to tell you what's in your data? Because in the age of AI, that might just be the more important question to answer.